Yeah, I'm professional. All right, chat. You got any questions? All right. Donations welcome to. All right. So what we did is we talked about last time. We talked about I'm gonna talk kind of fast today. We are talking about calculus with limit, derivative, antiderivative, and we talk about we can evaluate this limits using numerical approach. Just plug in numbers until you get closer and closer and closer, right? And we also talk about domain. Domain's denominator cannot equal to 0. If denominator cannot equal to 0, here x cannot equal to 1. So therefore, negative infinity to 1 and 1 to infinity. And if you use decimal, use a numerical approach, you're going to get 3. Any question about this part? No? We did that last time. Okay. We also did this one, but this class I probably didn't get to talk about it, is if inside a radical is greater than 0, so inside a radical is greater than 0, that is going to be your domain for certain parts. So it'll be x greater equal to negative 1. So x greater equal to negative 1 is going to go from here to here, but x cannot equal to 0. Why? Because if I solve denominator equal to 0, cannot equal to 0, I'm going to solve x cannot equal to 0, and that becomes negative infinity to 0, 0 to infinity. Because denominator equal to 0 is undefined. So if you set the whole thing equal to 0, or cannot equal to 0, so you cannot equal to 1. If you square both sides, move the 1 to the other side, x cannot equal to 0. So there's an open circle there on the number line solutions. Let me know if I'm going too fast. Yes.
Will there always be like a hole at 0?
Not always. In this case, yes, because in this case there is cannot equal to the denominator equal to 0. It's not a whole in this particular case. I think. Hold on a second. Is a whole? Yeah, it's a whole. Because there is other reason for that to happen. We're gonna talk about it later algebraically. But right now we can only plug in a number until we get very close to the number from both ends, though. Okay. Now, I think eventually this is equal to 2 or 3. I don't remember. Do you guys have write down the notes? It's equal to 2 or 3. Venetia, do you have write down?
Okay.
Yeah, I think the limit's equal to 3 or 2. I don't know. Let me try it. 2? Okay. So this is 2. Okay, so now we're going to talk about this graph here. We're going to talk about this graph, which is we're going to emphasize on this graph. So y is equal to absolute value x over x. Okay. Did we talk about this graph or no?
Yeah.
We did? Okay. What do you guys come up with the graph? What the graph look like? Okay, good. So that's good. So you guys gonna have a here and here, like this. But how does it come up to here? Algebraically, can I figure out why this look like this? So I'm gonna start with something called definition of radical. So definition of absolute value. Now that's something that you don't learn. Basically, its absolute value of x can change to two functions, a piecewise function at least. So this is equal to a piecewise function when x greater than 0, negative x when x is less than 0. You guys already know absolute value x look like a V graph, right? So it should look like this. Your phone should turn off. Whoever's phone, maybe it's mine. I don't know. I don't think it's mine. So y equal to x, and here is y equal to negative x. Is that okay? So you can write an absolute value function to two functions. And this two piecewise function is going to help you evaluate a lot of problems. For example, you can also do this day down too. If I have x minus 2 like this, what does that graph do? Goes left 2? Right 2. Okay, it's going right 2, right? So this part of this one is going to be x minus 2 when x greater than 2. So it's going to be this. And this is x minus 2. And the left side is going to be x minus 2, but it's going to be negative of that. So x is less than 2. Sorry, this is 2. This is 2. And this is less than 2. So it's going to be like this way. Make sure you know this side though. This side is going to be negative x minus 2. It's a negative version of the graph. So negative parenthesis x minus 2. If you distribute it, you'll find out is y-intercept side 2. The slope is negative. So that is going to be like this. So this is a positive version. This is a negative version of the same absolute value. It's that without absolute value. Now, how do I know this y equal to absolute value x equal to over x is that graph? We're going to show you visually because I hear y equal to absolute value x over x. Then I can write this in piecewise function. So if I write this in piecewise function, it's going to be, there are two graphs, right? When x is greater than 0, this is going to be x over x. Does that make sense? Because you take the positive version of an x. And this is the, and for the negative side, it's going to be negative x over x. So therefore, it's going to be absolute value 1 when x greater than 0, negative 1 when the x less than 0. And that's why you have two horizontal lines. When they reach 0, it's going to be 1. And from the left side, it's going to be negative 1. Let me know if I'm going too fast. Is this okay?
Can you go back?
Yes.
Negative, and then parentheses x minus 2.
Yeah, so this is x minus 2, this, and when it's x greater than 2, because this is 2, greater than 2 is this side. X is less than 2 is going to be this side. It's going to be negative version of x minus 2. It can, but I rather write down as negative x minus 2 because it's easier for you to cancel later if you need to cancel something. It just, the graph of absolute value is going to be like this, and this part of the function is always the positive version of x minus 2. This part of the function is going to be negative version of x minus 2. So now you notice this. Now what happened when limit x approaches 0? So limit x approaches 0 of absolute value x over x. Now graphically, you can understand that okay, so graphically, you can understand that if I approach this side, it's going to give you a negative 1. If I approach this side, it's going to give you a positive 1. Therefore, limit x approaches 0 in this particular case, it will be does not exist. Okay, why is that? So there are three situations limit does not exist. Limit does not exist at three situations. When limits x approach to a from the left side of f of x is equal to limit x approach to a from the right side of f of x. And if they're not equal to each other, if they're not equal to the same value, therefore limit does not exist. For example, if limits x approach to 0 from the negative side, that negative exponent is just 0 from the left side. You approach 0 from the, let's say, negative 0.1, negative 0.01, negative 0.001. Of absolute value x over x, this is equal to negative 1. And limits x approach 0 from the positive side of absolute value x over x is equal to positive 1. Therefore, limits x approach 0 of absolute value x over x is equal to does not exist. D and E does not exist. Not undefined, but does not exist. Yes.
So like if it goes like forward and backward and doesn't have a exact same value for limit, it's
Does not exist. Like that movie, Mean Girl.
Does the negative
Negative exponent just means approaching zero from the left side. So approaching zero from this side. And zero from the positive side. Somebody open the door for her. It's gonna be positive. So therefore, this is a 1, this is a negative 1. Yes, Armin.
the same rule like the
Vertical line test. No, the vertical line test is tell you like is a function or not.
because it's two.
It's not because we'll talk about vertical line test in a second. Vertical line test is a test whether a function is a function or not. And we'll talk about that in a second. So this is the first reason limit does not exist. There are total 3 reasons though. Second reason is unbounded behavior. So unbound behavior, which is the vertical asymptote. Which is if you have y equal to 1 over x squared. Y equal to 1 over x squared is a little bit different than normal reciprocal. It's going to look like it's going to look like this. Now this is asymptote as well. The reason why they both go up because of x squared. So that makes, if you plug in negative value, it's still going to be positive. So used to 1 over x is going to look like this, but 1 over x squared is going to look like this. So they both are unbounded behavior. Therefore, limit does not exist. Limit does not exist when you have vertical asymptote. Third reason is going to be oscillation. So if you ever have oscillation, limit does not exist. You're like, what's oscillation look like? Well, you guys never seen this graph before. So that means oscillation is going to be here. And you say, okay, well, what's oscillation look like? Well, for example, if I have f of x is equal to sine of 1 over x. You guys seen sine of x. You guys never seen sine of 1 over x. Especially what happened when limit x approaches 0 of sine of 1 over x. That becomes a question mark. We don't know. However, I'm going to plug in some values. And this value is going to be specially designed. Okay, I'm going to plug in the first value is 2 over pi. Can you tell me what happened if I plug in 2 over pi? Pi will be reciprocal, right? What is sine of pi over 2? 1. Is that okay? Now I'm going to plug in another one. So 2 over 3 pi. So what do you think 2 over 3 pi is going to be? 3 pi over 2. What is sine of 3 pi over 2? Negative 1. Is that okay? How about 2 over 5 pi? Which is what? Good. How about 2 over 7 pi? Do you see the pattern? Negative 1. 2 over 9 pi? 1. 2 over 11 pi? So you get a point, right? As this going, the bottom keep on increasing and top stay the same. What do you think the x value is going to, or what value? If top is 2, the bottom gets larger and larger. What do you think the x is going to? What? McKenna? As numerator is 2, bottom just keep on increasing. 1 pi, 2 pi, 5 pi, 7 pi, 9 pi. Where's that approaching? Caden? Liam? Connor?
I'm not sure.
What is 1 over infinity? Somebody say the right answer before. Almost 0. Because think about 1 over 10, 1 over 100, 1 over 1,000. What does that do? Just keep on moving the decimal places, right? So if top is stay the same, top could be any number. Let's say 100. The bottom go to a billion. It's still gonna be very small value. So this is approaching 0. But here it's gonna be oscillating between 1 and -1. I'm gonna tell you my mom. My mom is an Asian mom. As an Asian mom, they beat their kid, and it's normal. That's okay. You guys, white people, don't understand. Our parents does beat us. Connor says I understand. Connor don't. Huh? White people, your parents doesn't beat you.
My mom doesn't do it anymore, but one time, I think it was like 4 years ago, she was hitting my sister with a spoon and it broke, and she never hit it with a spoon ever again.
Okay.
So that was just a stop.
No, so my mom is I got in trouble, right? And she would use her hand with a ring on it, and she give me a forehand, like they playing tennis, right? She would give me the forehand, right? And that's all. When she give me a forehand, I just say look away, right? And then when I look away, she's like, "I'm talking to you. Why you don't look at me, right?" And she give me a backhand. And then so I look at her, and she's like, "I'm talking to you. Why you stare at me?" And she give me another forehand. And that just endless, just like forehand, backhand, forehand, backhand, forehand, backhand. It's like it, it's like I don't know, it's like kind of like tennis ball, like you're playing ping pong pretty much. So basically, in this situation, it's like that. It's a forehand, backhand, forehand, backhand, and then imagine that she have supernatural power, which is she does. She can go faster and faster. Okay, until infinitesimally faster, right? So all of a sudden she goes faster, back and forth, and all of a sudden she says stop. Like she say, did I just give you a forehand or did I just give you a backhand? But imagine that you are going so fast that you cannot tell, right? So you'd be like, I have no idea, right? So this is what happened, and now I'll show you what happened in terms of graph. This is what happened with this graph. Children, do not be your kid. You should. You should be your kid.
What?
I'm just kidding.
Never mind.
If be your kid with the right reasons, fine. But my mom always told me, like, I know it takes 3 minutes for the cops to arrive if you call the cops. Meanwhile, I'll kill you. But do you see that here? Do you see that is defined 1 or -1? It doesn't, because it's oscillating so fast. You see that frequency right here, right? You see the frequency. At first it was slow, 1, -1, 1, -1, but it gets faster, 1, -1, 1, and it's going infinitesimally faster when going towards 0. So it's actually just oscillating between 1 and -1, but it's happening so fast that you do not see. So you don't know which hand he gave it to you, backhand or backhand or forehand. Okay. And so that's that. Oscillation. Limit x approaches 0 in this case, it does not exist because there's oscillation. Because the graph's gonna look like something like this, right? And like this. I don't know. But it's so intense right here that you don't know how fast it's going. So you don't know whether it's -1 or +1 because it's not able to define. Got it? Next question. So I call it infinite slap. Brendan's mom doesn't look like she'll be. Brendan's mom's too nice. Right?
Yeah.
Your mom's too sweet. She's too nice to be. Jenny, does your mom agree you? Were you younger? Were you a troublemaker?
No.
Or why you got beat? Huh? B's? Oh, gray? Oh, you're about to get beat. I'm just kidding. All right, so that's that. Now we're gonna talk about this particular thing here. Fourth period we didn't get to here, or third period we're gonna get to here, so we're gonna kind of help them. How much time I have? Oh, good. We have enough time. Okay, so we're gonna go through it kind of fast. So the limit x approaching -2, what do you think is going to be? Raise your hand if you think you know. Hurry up. Yes, Armin. You think it's 3? Anybody else? 3, 1. Okay. Anybody else? Caden? Okay. Anybody else? Going once, twice. 3? Actually, it does not exist. Why? Because this is a -2, right? If I look for the single value -2 there, you had to look from the both ends. And if you look from both ends, they do not come up to be the same value. So therefore it does not exist. The first one does not exist. Because of the B and C. You look at the B, between -2 is this way, right? What is the -2 negative side? This is -2 from the left side. What's the -2 from the left side? It's going to equal to what? It does exist. It's actually equal to 1. Because it's approaching this way. Yeah, it's approaching -2 from the left side. It's approaching 1. Because limit is going to be slowly approaching, just like how we approach the black hole.
It would be because of the
A is because B and C. You look at C. C is a -2 from the positive side, right? If I have -2 from the positive side, it's equal to what? 3. So that concludes that limit x approaching -2, does not exist because they both reach different value. If they reach the same value, they will be existing. Now, what will be the next question? How about f of -2? How about f of -2? F of -2 is 3. Why that's 3? Because of the closed circle. Thank you, Benicia. So the solid dot is going to tell you that it's actually evaluation. So f of -2 just means what happened when x equal to -2, what is the y value? You don't look for the limits anymore. You don't look how they're approaching. You look at what is the value when x equal to -2. Does that make sense? The input is -2. What will be the y value? In this case, it's 3. So let me ask you one more question. What happened when limit x approaches to 2? Make up your mind. Which one is it? Baden, why do you think it's -1? That's an open circle.
Oh, yeah. Is there a point below that?
So what happened limit x approach to 2 here? Actually, Baden's first intuition was right. It was -1. Because when I reach the 2, I'm looking at both sides. How do they come up to be? So if I look at 2 from the left side, 2 from the left side is going to -1, right? And 2 from the positive side is also -1, because that is going to be -1 as well. So therefore, they both equal to -1. This must be equal to -1, because you have to look from the both ends. If I'm looking at limit, I'm looking at how we're approaching it. But don't look at it from here. How do we approach from here? We're not gonna approach there. Only the small region here. How do I approach this value? This is -1. Yes. Well, yes. If my limit approach is single value, let's say 2, then you should look at how they approach from both sides. Now I can ask you from one individual side or another individual side. Now, after something is asking for evaluation, the input and output.
So if you're looking at it from one individual side, then it wouldn't refer to.
If you look at for individual side, just look at an individual side. Okay. What happened to f2? -2. Good job. That's -2. What happened when limit x approached to 4? That's nice. Is correct because why? Because two different value. 4 from the positive side is what? 2. And this is a 1, right? So therefore does not exist. What's the f of 4? 2. That's it. Am I going too fast or are you guys understanding?
Why is it from the negative side 1?
Negative side is 1 because it's going from here to here. So this is a 1. What happened when x approaches 8 from the left side? It'll be 2. What happened when x approaches to 8? Does not exist. What happened when lemma x approaches to 6? What happened when lemma x approaches -6 from the left side? What happened when lemma x approaches -infinity? Oh, sorry, this one's wrong. -6 from the left side is -infinity. -6 from the left side is -infinity. What happened when x approaches -infinity? 2. Uh-huh.
Also, I wanted to ask, is it okay if we do during tutoring today? Because I haven't recorded.
No, if I made a movie, it would be like this.
What's up?
Are there retakes for the tests we took?
No, there's no retake, but you can actually try to come back and understand them.
Okay.
I need to turn on the video. Do you think you can come back after school, get it?
Yeah. You know physics?
No, I don't know physics. I can teach you physics some other time, but not right now.
Alright, thank you. Because I'm a little stuck right now. Also, Mariana told me to tell you this. He is struggling in California.
Really?
Yeah.
It's 3-dimensional. That's why I told people don't to take online.
She's taking it in person, but she's still struggling.
Told her to look up Professor Leonard, Leonard, on YouTube. She need to watch a lecture. She need to watch like 10 lectures before the actual class starts.
Well, it already started.
Yeah, but if she watch it, that professor will explain everything in much better than UCF professor. UCF professor is really bad.
Alright, thank you.
Leonard, Leonard.
Got it. Thank you.
I don't know what happened to everybody today. Anybody else miss the other test? I feel like there's one other girl missing the other test. When's she coming back? Okay. All right. That's a girl look kind of like you. Okay. Wait, that's Liliana or? Okay. Gotcha. Okay, so yeah, we're gonna keep on going. So right now we're gonna solve an equation. We're probably gonna so get your notes out. On here, check your attendance. Am I gonna see anybody's parents today? For open house? Huh?
My mom might.
Oh no. I should know your mom. I have her phone number and speed dial because of Max DeLong. So it's not your fault. It's more Max's fault. Diana Burfree is not here. Okay, so let me make sure. Yes. Yeah, we start a new lesson. Josette's here or no? Josette's not here. Oh, I don't know why so many absent. Mia. Vicente, I feel like I see him. Ben Souza, Camila, Emily, Andrew, Sydney. Okay, Liana is not here. Anna. That's on this side. Gaviola. Jocelyn. Jacob Lee. Olivia Lopez. Okay, Isaac. Isaac's in the back, right? Is Isaac here? Okay, Winston. I feel I saw him. Ashley, I saw him too. Samuel. Okay, Christopher Idias. Okay, I saw you. Okay, Apple, I saw you, I think. Okay, Emily. Amelia is not here. Janisha. Val. Larissa. Okay. Landon, I saw. Jordan. Okay. Miranda, I saw. Safar. Shante. Okay, Emma. Emma's here, right? Okay. Soon we're gonna be work in group, but not right now. But after the first or second test, we're gonna work in group. Right now, we're gonna work individually. I usually let student work in group because usually group has a group leader, and that way you can ask the group leader questions. But I need probably first 2 tests to determine who's group leader. Group leader is good that you learn to take in charge of things. You're gonna handle like the welfare of your groups. Some people is gonna be very strong group leader, and if you know what you're doing, right? But you can also help bring other people up instead of putting other people down. That's not the goal of doing that. So we're gonna start with simple questions today. Again, at very beginning of the year, beginning of the lesson, I will start with simple questions. So I'm gonna record this. If you guys don't know that I record a lesson, actually, some people say hello. Where am I from? I don't know.